All right, we're going to go over the 2.4 homework today. Number one, explain how to find the range of a data set. The range is simply the largest number minus the smallest number, or the difference between the largest and smallest. An advantage of using the range as a measure of variation is it shows you how far the data is spread out. A disadvantage is it does not take outliers into account. So if you have one number that's way out further than the rest of the data set, then it does not take account for that and makes it look like all the numbers are out there. Number two, explain how to find the deviation of an entry in a data set. Um, in order to find the deviation, you just take the entry minus the mean. What is the sum of all the deviations in any data set? It is all going to add up to 0. Number three, why is the standard deviation used more frequently than the variance? Because it gives you an idea of what it is, what the unit is, and not the unit squared. So like if we are measuring distances, standard deviation will give the deviation in feet as opposed to feet squared. Explain the relationship between variance and standard deviation. Standard deviation is just the square root of the variance. Can either of the measures be negative? No. Reason for that is variance is a number squared, which makes it positive automatically. Standard deviation is the square root of that, which is automatically positive as well. Given a data set, how do you know whether to calculate sigma or S? So that would be either population standard deviation or sample standard deviation. Usually it'll tell you in the problem like we surveyed 20 US adults. If it's 20 US adults, then it's going to be the sample because there are not only 20 US adults in all of America. Discuss the similarities and differences between the empirical rule and Chebyshev's theorem. Really, the differences are just in the way you calculate it. Empirical rule is hard set numbers. It's always going to be that 60, I think it's like 69% falls within the first standard deviation. Chebyshev's theorem is more flexible based on the data. And what must you know about a data set before you can use the empirical rule? You have to know that it is a standard bell curve. All right, number 9. Find the range of the data set represented by the graph. All you do is the highest number, 34, minus the lowest number, 24. That's it. So that will give you 10. Number 10. It's going to be 73 is your lowest number, and 96, 7, 8, 9. So it'd be 99 minus 73, or 26. Okay. Number 11, the depths in inches at which 10 artifacts are found are listed. Find the lowest number and the highest number. Your lowest number is going to be 20.7. Your highest number is 38.5. You just subtract those. 38.5 minus 20.7 is 17.8. So that's your range of the data set. Change 38.5 to 60.5 and not find the new range. So you do 60.5 minus 20.7. This just shows how an outlier would really affect it. Your new range would be 39.8. In exercise 11, compare your answer to part A with your answer to part B. How do outliers affect the range of the data set? It makes it look like the data is much more spread out. Okay, find population statistics is a lot of calculator work. All you're going to do is push your stat button. So you're going to push stat, edit, enter all your data in 13, 10, 12, 11, 7, 8, 6, 6, 10, 7, 12, 4, 6, 5, 2, 2. Push stat again, over to calc, enter on OneVeristats, and enter until it brings up all your stats. Now it wants to know what the range, mean, variance, and standard deviation is. So your mean is 7.56. Your standard deviation, this is going to be a sigma standard deviation. That's because it's all of the AFC teams, or for each AFC team. So that would be 3.4 for your standard deviation. Your range is the max minus the min, which would be 11. And I think that's all you had to find. Variance too. You find your variance just by squaring your standard deviation. So you do 3.37 squared. That would give you 11.36. Number 14, weight in pounds of all U.S. presidents since 1952. You just enter that data in. So you go stat, edit, put your data in 173, 175, 200. Okay, so you should have 10 data points. Push stat calc, OneVeristats. Your mean is 186.1. Your standard deviation, again, it's all U.S. presidents, so you're going to use sigma, is 18.44. Your range, if you scroll down, you can see what your min x and your max x are. So you just do 230 minus 160, gives you 70. And then your standard deviation is taking that 18.44 and squaring it. Gives you 340.03. All right, number 15. In exercises 15 and 16, find the range, mean, variance, and standard deviation of the sample data set. Ages in years of a random sample of shoppers at a clothing outlet. That would be just entering all your data in again. Just stat, edit, clear L1 out, and go with it. 15, 18, 19. And do OneVeristats. Your mean would be 17. Your range is 10. Your variance and standard deviation, finding the standard deviation first. Now this is a random sample of shoppers, so we're going to use S of X instead of sigma, so it will be 2.59 or 2.6. So then you do 2.6 squared, gives you 6.76. Number 16. Put it all in again. It's really boring, tedious work because you're just putting it all in the calculator. Okay, once you have them all entered in, go calc on var stats. Your mean is 281.35. Your S of X is 10.55. You can make it 10.6. Your range is 291 minus 264. Should be 27. And your standard deviation would be 112.36. All right, number 7. Number 17. Jeez. Both data sets shown in the stem and leaf plots have a mean of 165. One has a standard deviation of 16, and the other has a standard deviation of 24. By looking at the stem and leaf plots, which is which? Explain your reasoning. Okay, so standard deviation measures how far it's spread out from the mean. And so if you look at A, you have data that does not form like a bell almost. It's a little more spread out. If you look at B, the data is pretty much like a bell, right? Which means that the standard deviation is going to be smaller for this one because the data is not all over the place. Whereas this one, the data is more spread out and all over the place. So this is going to be 24 and this is going to be 16. Same concept applies to number 18. Both data sets shown in the histogram have a mean of 50. One has a standard deviation of 2.4 and the other has a standard deviation of 5. By looking at the histograms, which is which? So if you look at the first one, everything's packed in tight, close together. Look at the second one, it's way more spread out. And so if we go with A for the 2.4 and the deviation of 5 for B. You are applying, I can't even read that now. For jobs at two companies, Company A offers starting salaries with mu equal to 31,000 and sigma equal to 1,000. Company B offers starting salaries with mu equal to 31,000 and sigma equal to 5,000. From which company are you more likely to get an offer of $33,000 or more? Explain your reasoning. So you are more likely to get an offer of that much from company B. And the reason is because the data is more spread out away from the mean. You have a mean of 31,000 for the first one, and your standard deviation is 1,000. It lets you know that most of the data is closer to that 31,000. But with the second one, the data is spread out farther because the standard deviation is 5,000. Number 20, salary offers. You're applying for jobs at two companies. Company C offers starting salaries with mu equal to 39,000 and standard deviation 4,000. Company D offers starting salaries with mu equal to 39,000 and sigma equal to 1,500. From which company are you more likely to receive an offer of 42,000 or more? That would be company C. And once again, it's because the standard deviation is higher, which means that the data is more spread out. Number 21, you're asked to compare three data sets without calculating. Determine which data set has the greatest sample standard deviation, which has the least sample standard deviation. Explain your reasoning. So the one that has the greatest sample standard deviation is going to be number 2, and it's because the bars are the highest farthest out from the center. The one that has the least sample standard deviation is going to be number 3, and that's because you have a bar on either side of the mean or the highest bar and nothing out further. Number 22, the highest standard deviation is going to be number 1, because you have number 1, and it's because you have data spread out less centrally, and I'll discuss what I mean by that, than in number 2. So if you look at number 2, your data has this big peak here and then a number for each one after that. This one, you don't have such a high peak. You have 2 numbers and 2 numbers, then 1 number, 1 number. And so just dropping that peak down a little bit and spreading the data out to here and here a little more makes it so that number 1 is higher than number 2 or number 3. Number 3 is going to have your lowest standard deviation because you don't have any data points out this far. They're all in the center and then right next to it. Okay, number 23. The highest standard deviation is going to be number 2. It's because you have more points spread out here on the ends. The lowest standard deviation is going to be number 1. It's because all the data is packed in tight with no points out on the end. Number 24, 3 is going to be the highest standard deviation. And it's going to be because you have the high points out here on the ends. Number 1 is going to be the lowest standard deviation. And it's because you don't have any points out on the ends. All right, number 25, construct a data set that has the given statistics. Okay, so we need a standard deviation of 2 and n equal to 6. So I'm going to start with my center, and I'm going to call that 4. Then I need a standard deviation of 2. So I'm going to go 2, 2. Yeah. Actually, I'm going to go 4, 4 in the middle, and 2, 2, and 6, 6. Now you have a standard deviation of 2. But your mean isn't 5. Should have paid attention in the beginning. It's going to be 5, 5, 7, 7, and 3, 3. So start with the mean. 5, 5, 3, 3, 7, 7. That's it. Number 26, I need n equals 8, mu equals 6, and sigma equals 3. So I'm going to start with my mu. Make 6, 6, and sigma equals 3. So then I'm actually going to drop this down 3 units and go 3, 3, 3, and 9, 9, 9. So 3 units below, 3 units above, and that should work out pretty close. Number 27. Same concept. I have x bar equal to 9 and s equal to 0. So I don't want any deviation. That's going to give me 9, 9, 9, 9, 9, 9, 9. So I need 7 numbers. So now there's no deviation in those numbers because they're all exactly the same. Number 28, if I start with an x bar of 7, and drop down 2, 5, 5, and 9, 9. All right, number 29. The mean speed of a sample of vehicles along a stretch of highway is 67 miles per hour with a standard deviation of 4 miles per hour. Estimate the percent of vehicles whose speeds are between 63 miles per hour and 71 miles per hour. Assume the data has a bell-shaped curve. So for this one, this is one standard deviation within the mean. And so you can assume that since it has a bell-shaped curve, it would be 68% of the data falls within that range, because it would each be within one standard deviation of the mean. Remember, empirical rule says 68% falls within one standard deviation of the mean, and then it's like 95 falls within 2 standard deviations of the mean. All right, mean monthly utility bill for a sample of households in a city is $70. What is this with a standard deviation of $8? Between what two values do about 95% of the data lie? So you just go 2 up from that, so that would be 8 times 2, which will give you 16. 70 plus 16 is 86, and then you have to go 2 down from that also. So you do 70 minus 16, which will give you 54. So 95% of the data is going to fall between 54 and 86. Use the sample statistics from exercise 29 and assume the number of the vehicles in the sample is 75. Estimate the number of vehicles whose speeds are between 63 and 71. You just do 0.68 times 75. So 0.68 times 75 is going to give you 51 vehicles. In a sample of 25 additional vehicles, about how many would you expect to have speeds between 63 and 71? You would expect about 68 of them, because it's 68% of 100. Using the sample statistics from exercise 30 and assume the number of households in the sample is 40. Estimate the number of households whose monthly utility bills are between 54 and 86. You just do 0.95 times 40. That gives you 38 households. In a sample of 20 additional households, so you just do 60 times 0.95. You get 57. Speeds for 8 more vehicles are listed. Using the sample statistics from exercise 29, determine which of the data entries are unusual or any of the data entries very unusual. Explain your reasoning. So if it's above 2 standard deviations, then it's considered unusual. If it's above 3 standard deviations, then it's very unusual. Okay, so we're looking at data that's between 63 and 71 originally. And then you could go even further and say between 59 and 75. So 78 is unusual. 76 is unusual. And 82 is very unusual because 82 is above 2 standard deviations. 76 and 78 are both, or 82 is above 3 standard deviations. 78 and 76 are above 2. Number 34, it's going to be any data that's above 86 is just unusual, or below 54 is unusual. So 52 is below 54, that's unusual. If it's much further below, then it would be very unusual. In addition, we don't have any numbers on the high side that are very unusual, except number 98. That would be very unusual because it's above 2 standard deviations. Well, above 3 standard deviations is 98. 52 is below 2 standard deviations, but not below 3 standard deviations. All right, Chebyshevs, you're conducting a survey on the number of pets per household in your region. From a sample with n equals 40, find the mean number of pets per household is 2, and the standard deviation is 1 pet. Use Chebyshev's theorem to determine at least how many pets. How many of the households have 0 to 4 pets? So in order to do this, we figure out how many standard deviations from the mean it is. So you basically, it's going to be 2 standard deviations away from the mean because there's 2 pets, and you're looking at from 0 to 4. So that's 2 below and 2 above. So it's 2 standard deviations away from the mean. So you do 1 minus 1 over 2 squared. So 1 minus 1/4, which would be 75%. Then you do 0.75 times 40 to get 30 households would fall within that range. Old Faithful is a famous geyser at Yellowstone National Park. From a sample with n equals 32, the mean duration of blah 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 is 3.32 minutes and standard deviation is 1.09 minutes. Using Chebyshev's theorem, determine at least how many of the eruptions last between 1.14 and 5.5. So that would be I think it's going to be within 1 standard deviation of the mean. No, it would be 2 standard deviations of the mean. So once again, it's going to be 75%. It's going to be 1 minus 1 over k squared. 1 over k squared is 1/4. And so you do 0.75 times 32, which gives you 24. 37, mean score on a European history exam is 88 points with a standard deviation of 4 points. Apply Chebyshev's, so it's 75% of the data again. So, so 75% of the scores are going to be between, you would add 4 twice to the 88, so 88 plus 8. So 75% of the data is going to fall between 96 and 80. All right, number 38. The mean time in the finals for the women's 800-meter freestyle at the 2012 Summer Olympics was 502.84 seconds, with a standard deviation of 4.68 seconds. Apply Chebyshev's theorem to the data using k equals 2. So you would do 4.68 times 2, and then add that to 502.84. That would give you 512.2. And then you would do 502.84 minus 9.36. So you get 493.48. So then you would say 75% of the data falls between 493.48 and 512.2. That's all. All right, we will finish this up tomorrow.